Good day, everyone. Our paper is entitled Analyzing the Efficiency of the Top Non-Life Insurance Companies in the Philippines, Derivation of Common Weights in Data Envelopment Analysis using Goal Programming Approach. There have been many studies with diverse objectives regarding efficiency and performance evaluation in the financial sector, particularly in the insurance industry. In fact, these are two of the most prominent research teams in the field. Gurakani highlighted that performance evaluation is essential in assessing and designing companies' procedures and strategies. It is imperative to identify units with worsening performance to be able to make necessary adjustments and enhancements since it is expected that they should manifest improving performance through time. Efficiency measures also serve as alternatives to the accounting-based financial ratio of the industry performance, which considers the importance of operational and strategic decision-making. Data Envelopment Analysis or DEA is the most appropriate tool to use in analyzing efficiency of companies. DEA, first developed by Charles and Cooper, is a non-parametric mathematical method for measuring the efficiency of peer decision-making units or DMUs when there are multiple inputs and outputs. Based on linear programming, it is used to address the problem of calculating the relative efficiency for a group of DMUs. DEA has many advantages compared to other approaches. First is the convenience of handling multiple inputs and outputs. Second, it does not require an assumption of a functional form relating variables. Despite the wide use of the model, the conventional DEA is also faced with limitation. Traditional models allow each DMU to assess its efficiency by choosing the most favorable weights for itself to achieve maximum efficiency possible. Hence, difference in weights lead to many possible DMUs classified as efficient, making comparison impossible, and efficiency ranking of DMUs cannot be accurately distinguished. The challenge of non-standardized weights was addressed by the introduction of common weights. Here, flexibility is not permitted, and all DMUs are evaluated by identical weights. This addresses the issues of convenience and arbitrary assignments and non-comparability of efficiency of DMUs. As based in the study of Garakani, the researcher computed for the common weights using goal programming with the objective of minimizing the deviation from the actual efficiency and the maximum attainable efficiency of all DMUs or insurance companies. In the Philippines, there are 59 non-life insurance companies that are consistently remaining in the industry. However, for the purpose of the study, this is limited to the top 5 insurers based on 2017 gross premium written. The share of these companies comprises 50% of the market share of the whole industry. Benusep and Hemrit also restricted the number of insurers in their study based on market share. The following inputs and outputs are chosen based on gathered literature. For input 1, operation expense, benefit, claims and expense, general and admin expenses. For input 2, direct written premiums, reinsurance premiums. For output, net income, investment and other income. This research serves as an application of Karakani's model in the Philippine insurance industry setting. For each DMU, first stage and second stage are defined as follows. The two-stage process is efficient if and only if E sub 1 sub j is equal to E sub 2 sub j is equal to 1. Further, the overall efficiency is computed in Model 3. Thus, the formula of E sub 0 overall is given by using linear programming, the maximum values of E sub 1 sub 0 overall and E sub 2 sub 0 overall can be obtained by the following, respectively. Next, in the computation of common weights using GP, the objective is to minimize the deviation of the actual versus the maximum possible attainable efficiency and is represented by the following constraints. The following procedures summarize the steps implemented to compute for the identical weights. This table summarizes the overall and per stage efficiency scores E sub 0 overall, theta sub 1, and theta sub 2 that can be obtained by each DMUs. However, as discussed in the weaknesses of conventional and traditional DEA, maximization of the overall efficiency of each DMU would lead to differences in weights to be applied to the variable considered per insurance company. Hence, the goal programming approach was used in order to yield the common sets of weights that would be applied to all insurers with the objective that the deviation between the actual efficiency and maximum attainable efficiency is minimized. The table shows the calculated common sets of weights for the inputs and outputs obtained from the proposed model using goal programming. Comparing the efficiency values of stage 1 and 2, it can be said that in general, for all the years, all insurance companies are more efficient in the former stage than the latter. Meanwhile, analyzing the trend of the overall efficiency of each DMU, only DMU1 has increasing efficiency score as time passes by. DMU3, on the contrary, has decreasing efficiency score while there is no obvious and general trend over the year for DMUs 2, 4, and 5. The outlying negative value of DMU5 for the year 2016 is due to the impact of the large magnitude of loss the insurance company has attained for the year. Data also suggests that none of the DMUs is consistently and dominantly efficient across all period reviewed. Findings shows that there are 3 DMUs identified as efficient, particularly DMU3, DMU1, and DMU4 for the year 2015, 2016, and 2017 respectively. DMU1, in general, has the highest values of input 1 variables. That is, this insurance company, among the others, has the largest expenses in terms of operation and have incurred large losses. However, it has also attained the highest direct premium written across the years. Hence, it can be said that this insurer, as large operating company, is maximizing its retention on risks being written. Moreover, high efficiency and profitability can also be attributed to each high income coming from investments as compared to other. DMU4, on the other hand, has been able to manage and minimize its administrative expense and benefits and claim, while producing the highest net income in general among others. This highlights the strength of this insurer in risk selection and risk evaluation. Overall, this insurer has the highest reinsurance premium across the years. In contrary to the techniques and approach of DMU1, DMU3 has managed to accept risk yet cede a portion or percentage to the reinsurer for risk transfer so that in case of large losses, not all will be absorbed by the company. As a summary and conclusion, by applying Gherkani's DEA model to the data of top 5 non-life insurers, the researchers were able to develop common sets of weights using goal programming. Ranking of the insurance companies were also obtained. Results revealed that considering all years, DMU3 is the most efficient among all. For further studies, we recommend the application of the SET model to all the existing 59 non-life companies as well as life insurance firms. Moreover, future researchers may compare the proposed model with other ranking models such as super efficiency models, CCR, and BCC models. With that, thank you very much.